Station, this is Houston. Are you ready for the event?
I'm ready for the event.
Winter, Wisconsin School District, this is Mission Control Houston. Please call station for a voice check.
Want Jim to talk now? No? Go. No.
Station, this is Winter, Wisconsin School District. How do you hear me?
I've got you loud and clear, and I'm looking forward to talking to everybody today.
Good. I'm going to hand it off to Mr. Zopp. He'll introduce the students and their questions. Thank you.
Thank you, Mr. Ide. Can we have our first student come up, Miss Lacey Martin, 11th grade.
With regards to the rodent research and the scientific method, is there similar research going on Earth or the ISS that will be used as the control so the results of both can be compared?
Actually, yes. Rodents and other animals have been used for research for years, and most research hospitals have a program actually in the hospital where they're doing different kinds of medical tests in support of development for medical research, for drugs, for diseases, for various things. So we're using that technique as an analog up here to try to isolate the effects of weightlessness. Great question.
Jason Nucky, 9th grade.
With regards to the wettability study, when measuring liquids in science class, we learned to read the meniscus. Is there a meniscus in microgravity, and how do you make accurate liquid measurements?
Oh, absolutely. In fact, the meniscus is formed by, there's forces, right? Gravity forces down there. There's also surface tension forces, cohesive, adhesive forces, adhesion, cohesion. And you're studying all of that. We have the same forces up here, absent gravity. So liquids do behave with their properties, and you take the gravity away so you can learn lots of things. In fact, we had an experiment that's been going on up here for years called capillary flow experiment, which is studying the control of liquids through different shapes of using capillary forces so that we can control the liquid, for example, in fuel tanks of satellites and other liquid applications. So it's got a lot of applicability up here.
Sage Spinner, 4th grade.
What kind of cage or enclosure is being used to house the mice used in the rodent research study?
That's a great question. In fact, we in the crew, we're in an enclosure called the International Space Station, and we roam around inside. But life support is provided for us inside. Mice, of course, can be a little bit dirty, so we have them inside their own habitat. It's designed to keep them very comfortable and very safe. It provides them the right atmosphere to breathe. It also provides them food and water, and it's designed also to be maintainable so we can clean it. So they have their own little habitat, boxes about this big, a couple of them, to keep the mice safe and secure.
Cody Coleman, 11th grade.
What is the form of power on the ISS? Is solar energy used to charge batteries and then everything is run on DC power?
That's a good question. We have a very extensive power distribution system integrated into the International Space Station. And we use the sun's energy, which illuminates on solar arrays. In fact, when you watch the ISS fly over from the ground, which many of you I know have, it's very bright. And it's so bright because of the sun's reflections off the solar arrays. The sun's energy is collected in the solar arrays and turned into electricity and charges batteries, large batteries that are mounted outside. so that we can continue to have power inside when we're in our orbital nighttime. And then that power is distributed around the space station. It's reduced in voltage, but it's mostly direct current, 120-volt direct current through the station. And then we have inverters on board the station to turn it into AC power for different users. And we distribute the power to all the modules inside the space station to run the pumps, to run the fans, to run the experiments, to run the lighting, all of the equipment that we have on board.
John Larson, 10th grade.
Do the mice used in the rodents research study just float around in their enclosure?
I'm sorry, could you repeat the question? I didn't quite hear it.
Do the mice used in the rodent research study just float around in their enclosure?
Well, the enclosure is not that big. It's a box about like this, and inside they have some wire mesh to be able to climb on, and they actually spend a lot of time running around the outside of the enclosure, so they're able to grab a hold just fine, and they acclimate. They have acclimated very well to zero G, and they do very well, acting like rodents do, often just mostly running around on their own. And interacting with one another as they normally do on the ground.
Jasmine Gable, 8th grade.
How long does it take to notice the loss of muscle and bone on a mission?
Well, you go through an adaptation the first several days you're up here, getting used to weightlessness, and your whole body goes through a little adjustment. For example, our spine stretches out, so you might have a minor backache. Your leg muscles are not being exercised the way they are on the ground, just supporting our own body, so they might get a little bit uncomfortable. However, we exercise up here every day. And over the first 2 weeks or so, you acclimate, you go through that initial acclimation, and then exercising every day, we maintain our bone muscle and our bone and muscle strength. So other than the acclimation to zero G, you really don't notice it until after the flight, when we measure our muscle strength and also our total bone density. We've developed countermeasures over the years which will help mitigate the loss of both muscle and bone, and those mitigation efforts have been very effective. So I'm hoping to get back and have no essential muscle or bone loss.
Brock Aber, 8th grade.
How are the mice in the rodent research study fed?
They're given food bars which are introduced inside the habitat, and they have access to it, and they just feed off the bar. In a similar way, they have access to water, so they're able to drink water as they please. And then there's a ventilation system in it to help keep the habitat clean. However, there is some maintenance required to keep it clean, just from the waste products. But overall, the habitat is performing very, very well to keep them healthy.
Max Wiley, 9th grade.
Have you been able to offset the loss of muscle and bone mass and microgravity by exercise with the machines you now have on the ISS, or is that also a goal of the Med2 experiment?
Well, we have many goals in terms of continuing to understand the environment and the effects on the human body, to include bone and muscle loss. Over the years, we've upgraded the equipment on board, which has greatly improved our performance and our ability to maintain both muscle and bone. We have a new treadmill that came up. Actually, it's not so new anymore. It came up about 7 years ago or so, and it performs very well. And we use a harness with bungees to pull us down into the treadmill to produce the load that's equivalent to gravity on Earth. We also have a resistive exercise device, which is the equivalent of a weightlifting machine, and that was upgraded about 8 years ago. We call it the ARED, or the Advanced Resistive Exercise Device, and it has done very well, much better than the earlier equipment that we had on board. It's more robust. It allows you to pick up more load, heavier load, which is more equivalent to the exercise you might get on the ground. So, but we still have research to do. We still have answers to find to questions that both we already know, and as well as I'm sure there will be future questions that come up that identify things we don't yet understand.
Travis Shanks, 10th grade.
Have you had any issues with the rodent research mice?
No, actually, the research program has gone very, very well. The mice have stayed healthy. We watch them very closely. In fact, there's a camera inside the habitat, so the flight control team on the ground in Huntsville, Alabama, can also watch them. We have sensors in there to keep track of the environment that they're living in, and they have stayed very, very healthy, very lively, and have supported the research program very well. So no issues really to speak of.
Blake Martin, 5th grade.
What is your favorite thing to do in space?
Well, my favorite thing, of course, is to enjoy a weightless environment and to be able to do all those things that you can do, as you might imagine, without gravity. So that's a lot of fun, just with our, with the stuff that we have. Of course, it can be a challenge too, because everything. I've got a little piece of Velcro on this food package. Anything that's not attached to the wall or isn't tied down somehow will drift away and float away. So we're losing things all the time, but eventually they're found. One of my favorite things, of course, is to get in the window and view the Earth and to take photography. And this is an example of one of the cameras and a large lens. This is a 400-millimeter lens. And much of the photography, which you might have seen that we've sent down, is taken with a lens like this. We also have wide-angle lenses and then lenses in between, and we even have one that's bigger than this one, an 800-millimeter lens. So that becomes one of my favorite things to do up here, is take pictures out the window just to capture the experience for you and everybody else on the planet to be able to enjoy.
Samantha Harris, 11th grade.
Did you bring any mouse traps with you, just in case the mice in the rodent research study get out?
Among the crew, we've joked about that, wondering if a mouse got out, if we'd ever be able to find him, because there's lots of nooks and crannies up here. Eventually, we could probably lure him out with a little bit of food. But the procedures that we have make it very, very unlikely that a mouse could ever get out. They're always contained, even when they're transferred from the habitat into the work volume that we do the studies in. They're contained in a transfer container from the habitat to the glove box. So they're always contained. We always have controls to make sure that they don't get away. It would be very tough to find a mouse on board the space station, I'm sure.
Curtis Thompson, 4th grade.
How do you know where to land when you come back from the ISS?
I missed part of the question. How do I what when I come back from the ISS?
How do you know where to land when you come back from the ISS?
That's a great question. Actually, the flight control team in Moscow, the Russian flight control team, they do all the planning for all of the Soyuz operations, to include undocking from the space station and landing. We land in a very specific area in central Kazakhstan, which is halfway around the world from where you are. I say in the middle of nowhere, because when in the landing site there's nothing as far as you can see in every direction except just flat fields, open fields. But they find out exactly when we need to fire the main engine of the Soyuz. We burn the main engine for a little over 4 minutes, flying backwards, so that we slow down. We start that burn when we're flying over the southern tip of South America, so that we will re-enter the atmosphere and then have the parachute open so that we end up right over central Kazakhstan. So we fire the engine over South America. We fly across northern Africa, across the eastern part of the Mediterranean Sea, across Turkey. Then the parachute opens a little bit beyond that, and we drift down and land in central Kazakhstan. It's all mathematics. I know you're studying arithmetic and advanced mathematics, perhaps in high school. That's what it takes to figure out how to do that very precise landing.
Albert Blair, 5th grade.
What are you personally researching, and what will be done with it when the experiments are finished?
We're doing a lot of different research on board. Every day, just about, we're doing some kind of an experiment. And we on board, we're not the researchers per se. We're more like lab technicians. So we will execute the experiment, and we send the data down to Earth, where the researchers for each experiment, there's a team for each experiment, and they take that data and they add that to the data pool, which might spread out over years to collect all the data to get the questions answered to their particular hypothesis. The research that we do on board covers the whole spectrum of science, all the science topics that you can imagine, material science, fluid dynamics, plant growth, cell growth, DNA, RNA studies. But perhaps the bulk of the studies, or much of the study, and the study that's most interesting to me is the study of the human body. Like this morning, I was doing ultrasound scans of the legs and of the muscles in my legs, trying to understand again the impact on the muscle strength using our exercise protocol that we have on board. So I see the data. Might be years before I see the results, but very, very interesting science we're conducting here on board.
Macy Miller, 4th grade.
Are they trying to find a way to put planet animal life on the moon?
Well, the moon, and sometimes we talk about Mars, the moon and the Mars do not have an atmosphere that will support life. In fact, the moon doesn't have an atmosphere at all. There's no ready source of water. There's no food. There's none of the other things that it takes to support life for people, and that's also true for animals. So if we were going to take an animal to the moon, for example, a pet or any kind of an animal, we would have to take everything that animal needs to support its life, to include a habitat, just like this space station is for us, and to take an atmosphere and the equipment to maintain the atmosphere, to remove the carbon dioxide, to add oxygen, to maintain a healthy atmosphere free of contaminants, to remove the humidity, and all of the food and water necessary. So theoretically, it's possible, but we'll have to take all the support to maintain the life of the animal.
Brooklyn Pettit, 5th grade.
What kind of training do you need to do to be in space?
Oh, my goodness. The training goes on for years up here. In fact, it used to take about 4 years to prepare for a flight like this. Now we've gotten it down to about 2.5 years or so through efficiencies. But it covers the whole spectrum. We have to understand all of the systems on the International Space Station, as well as the Soyuz spacecraft. We have to understand how to repair it when it breaks, and we have repair parts for all of the systems on board. So maintenance and repair. We have to train to respond for emergencies. We have to train for all of the science experiments that we've already talked about, and many more. We don't often have a doctor on board the crew, so many of us have medical training so that if we have an emergency, a medical emergency or a medical problem, even a non-emergency, we can respond to that emergency or treat that medical issue. So we have all of the equipment that you might imagine in a small emergency room. And then there's many other things. All the other functions, we can't call down the street and get an electrician or a plumber, for example, to come and fix something. So we need the training for that as well. And then there are many more topics that also we spend time training on.
Jeff, our last question is going to come from Alexis Rudnicki, an 8th grader.
What is one of the main projects or most important projects you are working on right now?
Well, from my point of view, in terms of categories, one of the main things that we're studying that's very important for future space exploration is what I've alluded to already, the impacts on the human body in a weightless environment, so that we can mitigate those impacts, fully understand them, and be prepared to leave Earth orbit to another destination for a long period of time. And we've talked a lot about muscle and bone. We also have an issue with eyesight. Some people have been impacted with their visual acuity. We don't fully understand that. So we're doing some studies to try to understand that, to try to come up with some answers to mitigate that. So study of the human body is probably the most significant from my point of view because it's going to support future exploration of human spaceflight.
Jeff, that concludes it. We'd like to thank you and NASA for continuing to do outreach like this. It helps to inspire our next generation of scientists. Godspeed, and we look forward to having you back on having your feet back on the ground safe and sound.
Thank you very much, and thank you for your enthusiastic support. I hope you're able to follow along, to see some of the photography and video that we're sending down, and maybe see us fly over once in a while. I know just this morning we flew over northern Wisconsin, and I knew today was our conference was coming up today, so that was a great timing for that Passover. I look forward to coming back and visiting you again in person.
Thank you, Jeff.
Station, this is Houston ACR. That concludes the event. Thank you.
Thank you very much.
And thank you to all the participants and guests at Winter, Wisconsin School District. You all had some great questions, and we really enjoy listening to them here in Mission Control. Station, we are now resuming operational audio communications.